Hello class, you are welcome back to Larbi Premium Consult. In today's video, we are looking at differentiation from calculus. Because calculus is one of the branches of mathematics, so we are going to look at differentiation in this case. So if you are new here, kindly make sure to subscribe and like this video. Make sure to like this video so that others can also get the benefit to learn from this channel. So without wasting my time, let's move straight away to our discussion, our topic for today, differentiation. What is a differentiation? Differentiation has to do with the process of finding the derivative of a function. Finding the derivative of a function. Find the derivative of a function. And the derivative of a function here can also be called a derived function, and its coefficient. So that's what I mean by what differentiation has to do with the process of finding the derivative of a function. A derivative of function here remain a derived function and a derived what coefficient. So as we move along, you understand why we have a derived function and a derived what coefficient. So that is generally the meaning of what a differentiation. We want to find a change that exists between what two quantities. So once you hear of differentiation, you are talking about what a change that exists between what two quantities. Let's have this one clear. Differentiation, we are talking about a change between two quantities. Let's say, what is the change with respect to the speed of a car and its time? As you speed up, or as the car speeds up on the road, you realize that the time that it takes to cover will be much more, let's say a particular kilometers will be much more lesser. But then when it slows on the road, the time that it will take for him to cover that first distance on the road is going to be a bit longer. So that is what differentiation also comes in, to find out what change will exist when there is a change in one quantity with respect to its influence on another. So we are talking about a change between two or more quantities, and that's what we call differentiation. Find the derivative of a function. I believe that is clear, right? So that is what we need to know when it comes to differentiation. Right. So let's move straight away, talk about rules of differentiation. So we just zero in to talk about straight away rules of differentiation. Rules of differentiation. So that's what we're going to talk about in this case, rules of differentiation. Generally, we have the general rule for a differentiation. We are saying that if I have y to be equal to x to the power of n, we are saying that to differentiate a function in this case, when you differentiate the y is going to be the change. When you differentiate the x, y is going to be the change. That's what you're going to look out for. We are saying that to differentiate a function, the differential of y is going to be dy going to be d multiplied by what y. So you call dy. Because you are causing a change with respect to x, you are going to call the division going to be dx. Please be careful here. Here, what we want to know here is that you want to differentiate two quantities. Here is what y and what x, and you want to find a change that exists between these two quantities. And when you differentiate y, we call it, the end result becomes what dy over dx. It becomes what dy over what dx, as I've written here. But when you want to differentiate the x, the rule is that you multiply this exponent by the coefficient of x here, which is what 1, and then you subtract 1 from the exponent. So here it becomes n multiplied by x multiplied by x. Okay, then you have your n repeated and subtract 1 from the n. So that is the base rule when it comes to differentiation, the general rule for differentiation. So here it becomes your dy over dx which is equal to n x n to the power of -1. That's n minus what? 1. So that's the general when it comes to differentiation. So let's say if I have, let's say y is equal to, let's say, a to the power of, let's say, n. Remember, here we are going to differentiate y with respect to what? A. So you're going to tell me that here it is what? Differentiate y, differentiate what? A. At any time you differentiate y based on with respect to quantity that you are differentiating, that is going to give you the effect. So here I was differentiating with respect to a. That's why I have here to what? The x. And here I'm differentiating with respect to what? A. So that's why I'm having here the y over what? A. I hope that is clear. So here is going to be n, going to multiply the a, the coefficient of a, which is 1. Okay. And I'll subtract 1 from the exponent. So that's the general rule when it comes to differentiation. That's the general rule when it comes to differentiation. So let's take an example so that you appreciate what I'm saying much more better. You appreciate what I'm saying much more better. Let's take an example. So example 1. Example 1. Example 1. If I have y to be equal to, let's say, x to the power of 2. What is the differential of y is equal to x to the power? So find dy over dx. Find dy over dx. That's a change. Is that okay? So here, when I differentiate y, so I'll have y to be equal to what? X squared. I hope that is clear. So when I differentiate y, it's going to be what? Dy, and respect to which quantity am I differentiating y with? Is what? X. So it's going to have here dx. Always important to know the quantity upon which the two quantities are into relation. Yeah, you need to know the two quantities that are into relation that you can have their differential. It's always important. So here is what? Y and what? X. So it becomes what? So the general rule is that after I differentiate the y with respect to x, here for me to differentiate, all I will do is to multiply the 2 by the coefficient of x, which is what? 1. So it becomes what? 2 multiplied by the coefficient of what? 1. So any number multiplied by 1 is the same as the number. So I'll have the x repeated again, then I'll have the 2 here, and I'll subtract 1 from the 2. So it's going to be dy over dx, which is going to be what? 2x. Because here 2 minus 1 is going to give me what? 1. Then I'm left with what? X to the power of 1 is the same thing as what? X. I believe that is clear. So that's how your answer is going to be. You're going to get what? dy over dx equal to what? 2x. I believe that is clear. Let's take another example and let's see. So let's take another example and let's see. Let's say I have y to be equal to, let's say, y to be equal to, let's say, a to the power of, let's say, 3. I'm asked to find the derivative of y is equal to the function y is equal to a to the power of what? 3. So here, if I want to differentiate y, it becomes what? My dy by which quantity am I differentiating y with, which is what? A. So it becomes what? Dy over what? The a. And that's going to give me, so here I multiply the 3 by the coefficient of a, which is what? 1. So it's going to be 3 into bracket 1, and I'll repeat the a, which is what? A. Then I'll subtract 1 from the exponent, which is 3. So it becomes what? 3 minus 1. So then it becomes dy over the a, which is equal to 3a squared. So that's the general rule when it comes to differentiation. I believe that is okay. All right. So let's take note of that. So let's take more examples and let's see. So always just multiply the power or the exponent by the coefficients of that quantity, and then you can find and subtract 1 from the power so that you can find the derivative or the differential of that function. So here, as we were saying, this how you're going to get the derived function is going to be your dy over dx, which is this, and the derived coefficient is going to be this one, n. That's the derived coefficient, and Your derived function is going to be your dy over what? Your dx. And the derived coefficient is what? The n, as I've indicated here. This is your derived what? Coefficient. This is your derived what? Function after the change. So that is something that we need to know when it comes to differentiation, right? So let's take more examples. So let's say I have this one, example 3. As I have a function y is equal to, let's say, 3x to the power of 4, and I'm asked to differentiate this. How would I do that? We know that I'm differentiating y with respect to what? X. So my derived function here is going to be dy over what? Dx. Is that okay? Meaning that differentiate y, differentiate what? X. So when I differentiate y, is dy over what? Dx. So it's going to be, so here I'll multiply what? The 4, this 4 by this 3. Is that okay? So it's going to be 4 multiplied by what? 3. And I'll repeat the x with the exponent of what? 4. So it comes what? X to the power of 4, and I'll subtract 1 from the 4. Is that okay? So here I can say that my dy over the x is going to be 12 plus 3 multiplied by 4, going to give me what? 12. And now I subtract 1 from the 4, I'm going to get x to the power of what? 3. And that is going to fetch me my result in that case. So it's going to be x to the power of 12x cubed, and that is going to be my dy over dx in that case. So let's take note of that. So let's move on and talk about differentiation of sum and difference, more like differentiation of addition and subtraction. That's what we're going to look out for. So let's look at it here. So differentiation of sums and difference. Differentiation of sums and difference. What I mean here is additions and then subtractions of what? Differentiation. We want to find how that these two quantities also work in this case. So let's see how we go through in that case too. So here we just try to take an example. So far as we know the base rule for differentiation, just work an example so that we are good to go in that case. So let me take an example 1 under this. Example 1. Example 1. If y is equal to, let's say, x squared plus 2x. Let's say y is equal to x squared plus 2x. What will be my dy over dx? Therefore, dy over dx is going to be question mark, right? So let's see how we resolve this. So here I have my solution down. So I can say that y is equal to what? X squared plus what? 2x. X squared plus 2x. I hope that is clear. Okay. So now, if I differentiate y, it becomes what? Dy over what? Dx. So we are saying that we differentiate y, differentiate x, because the quantities that are involved here are just y and what? X. So once I differentiate y, and I'll do the same for also the x. So the base rule is that you multiply the 2 by the coefficient of x and you subtract 1 from the exponent. So here you're going to be what? 2x, right? Going to be 2x. Going to be 2x. So once you know the formula right, you can straight away write your answer so that you're good to go. Plus, I know here is what? 2x, okay, but here the coefficient is what? 1. So all I will do is multiply this 1 by this 2. So that we're going to get what? 2. And I'll subtract 1 from this. So I'm left with what? 0. So x to the power of 0 is what? 1. So in number multiplied by, I'm going to get you the same what? Number. So therefore I can say that my dy over dx is equal to what? 2x plus what? 2. Or better, so I can write in this form, dy over dx is equal to 2 into bracket x plus 1. That's going to give me in a more factorized way so that it gets your answer in that case. So let's take note of that. So let's try another example so that we move on to the next example 2. Find dy over dx of the function y is equal to b cubed minus 2b squared plus 3b. So how are you going to deal with these two? So here it's an addition and subtraction, a function, right? So that we function. It's a cubic function, more like a cubic word function, cubic function. So here we are differentiating y with respect to what? B. So I'll have my solution down. So I can say that y is equal to b cubed minus what? 2b squared plus what? 3b. I believe that is okay. So here, if I differentiate y, it becomes what? The y. And which quantity are we differentiating y with? It's what? The b. Take note. So here it becomes what? I'll multiply the 3 by the coefficient of b, which is what? 1. So it becomes what? 3. And I'll subtract 1 from the 3. So it becomes what? B squared. I believe that is okay, right? Minus. Then I'll also multiply the 2, these 2, by the negative 2 here. So it becomes what? Negative 4. And I'll subtract 1 from these 2. So it becomes what? B. I believe that is okay. Yeah. And then I'll do same for the 3b. Here, plus. I know the coefficient of here is what? The exponent, is what? 1. So I'll multiply the 1 by the 3 and I'll subtract 1 from the exponent 1 here. So it's going to be 3, then b to the power of what? 0. Is that okay? So therefore I can say that dy over db is going to be 3b squared minus 4b plus a number to the power of 0 is what? 1. So that's going to give me what? 3. And that is going to be my answer in that case. So let's take note of that. So that's the differentiation of sums and differences, more like addition and subtraction of what? Differentiation. So let's look at differentiation of a constant. That's what we just learned on how to differentiate sums and what? Different. That's addition and subtraction of a differentiation. So here we are moving on to differentiation of a constant. So if you have a function, let's say if I have a function y is equal to, let's say, k. How do you differentiate this function? How do you differentiate? That's what we're going to look out for in this case. And we are saying that at any time you differentiate a constant function, you're going to get what? 0. And how do you derive that 0? Let's see how we go through. So in this case, I have y to be equal to what? K. So I can say that y, I can write y as the same thing as, y is equal to k as the same thing as y, which is equal to k, let's say, multiplied by x to the power of 0. I cannot write in this form. Is it true or false? It's true, because I can know that any number to the power, I can say that any number to the power of 0 is going to be what? 1. So 1 multiplied by k is going to give me the same thing as k. Is that okay? So once I'm able to rewrite in this form, then I can start my whole approach, or the rule for differentiation, general rule for differentiation. So I can say that here, when I'm differentiating y with respect to what? X. That is the variable that I'm dealing with. So in this case, it's going to be what? My dy over my dx, which is equal to, so once I'm done with the y, I come to x. So you said the base rule is that you multiply the exponent by the coefficient of the x and you subtract 1 from the exponent. So here is going to be 0 multiplied by k, and then I'll repeat my x with 0 and I'll subtract 1 from it. Any number multiplied by 0 is the same thing as what? Any number multiplied by 0 is what? 0. So if I have 1 multiplied by 0, it's the same thing as what? 0. So here, I won't even look at this. All I know is that any number multiplied by 0 is 0. So I can therefore say that, therefore, my dy over dx is equal to what? 0. And that is all. So anytime you differentiate the constant function, you get what? 0. You get 0. So what will be for this? If I have, let's say, example 1, like this. If I have y is equal to 3, I can say that my dy over dx is going to be So in this case, I'm writing straight away. It becomes what? 3. Sorry. It becomes 0, 0 multiplied by 3 x to the power of 0 minus 1. And that's going to give me divided over the x is going to give me what? 0. So don't worry yourself. At any time you see the differentiation of a constant, just repeat your answer as divided over the x, or based on the quantity you're dealing with, tell us that it's what? It's 0, and that is all. So that is the base rule that we need to know when it comes to differentiation of what? A constant. I believe that is clear, right? So let's take note of that. So try this for me. Work this one out and let's see whether you have gotten it right. Example 2. If I know my a to be equal to a to be equal to 1 over 2 as my function, then what will be the answer? Is going to be what? So here the function is what? A. So I can rewrite this by saying that it's going to be a is going to be, let's say, 1 over 2 with respect to, let's say, x to the power of what? 0. I can write in this form. The same thing as a is equal to half, because a number to the power of 0 is what? 1. So therefore I can say that I will differentiate a with respect to what? Differentiate what? X. Respect to differential of what? X. So that is going to give me, straight away I can say that the 0 is going to multiply the half. Alright, now repeat my x with 0 and subtract 1 from it. So I know a number multiplied by 0 is what? 0. So therefore I can say that my dA over the x is equal to what? 0. And that's going to be my final answer in this. So at any time you differentiate the constant, you get what? 0. So let's take note of that. Let's continue to talk about differentiation of an exponential functions. An exponential, I think we have already done that, but then here we want to talk about a special exponential function. So let's look at differentiation of an exponential function. So we just learned about differentiation of a constant. We said at any time you differentiate a constant, then you get what? 0 in that case. So let's look at how we also differentiate an exponential function, and this is a special one. So if I have y to be equal to, let's say, e, there is this, that's an exponential. It's more like business as e, but this is how we actually write it so that you can see it well. It's like more like a slant e. A slant e. Let me write it well. A slant e. More like a slant e. So if I have y is equal to this exponential with a function on top, how are you going to differentiate this function? And this symbol or this sign, you always see it on the calculator. If you have scientific calculator 991 ES, you see it there. It's an exponential. So how do you also differentiate it? It has a value actually, but then we are not looking at the value. We are looking at how we differentiate such function. If you have y is equal to that symbol, that e function, that slant e function, that with a function on top as an exponent, how do you differentiate that in that case? So it's the same principle that we know for the general rule for differentiation. The same that works here, but here the case is that here you differentiate the function that is at the top here. I mean the f of x. You're going to differentiate the f of x. Then you multiply the f of x. After the differential, you multiply by the coefficient of for the e, and that's going to go that you repeat it. It's like more like you are repeating. So this is what you're going to do. It's simple. Just stay carefully here. It's simple. Just stay carefully here. When you differentiate this function, it becomes here differentiate with respect to what? Differentiate with respect to x. So it becomes what? Dy over what? Dx. Which is going to be. So all I will do here is to differentiate the f of x here. When I'm differentiating the f of x, it becomes what? F prime of x. This f prime of x is the same thing as the first differential. When you get to high derivative of differentiating of a function, you understand this f prime of use here. So at any time you differentiate the function in this form, we call it f prime. That's the first differential. So f prime of x. Then you multiply this f prime of x that we differentiate here with the exponential symbol here, which is the e, okay, and you repeat this function again. You repeat it again on top here. So it becomes what? F of what? X. I believe you have gotten. So first you differentiate the function at the top here and you multiply by the coefficients of that e. Let me call it e for now. For the benefit of explanation, let me call it e so that you understand. So when you differentiate, it becomes what? F prime of what? X. Alright? And then after that, you repeat that same what function that was given as an exponent on top of what? The e. And that is going to be the differential of an exponential function. So let's take an example. So let's say, example, if I have y to be equal to that small e, and let's say here is 5x plus 2, and I'm asked to differentiate this function, how am I going to go by the differential of this function? So here is going to be dy over dx, okay, because I'm differentiating to x. Now we differentiate the function here. So here you know the normal rule, addition and subtraction of a differential. So this is an addition of what? Differential. So I'll differentiate them individually. When I differentiate the 5x, is going to be what? 5. Because here the coefficient of the exponent is 1. So when I multiply the 1 by 5, I'm going to get 5. Now subtract 1 from the 1 as an exponent, I'll get what? 0. In a multiple of 0, going to give me what? 1. So here you're going to give me what? 5. And when I differentiate the constant, which is a 2, I'm going to get what? 0. So it becomes what? Then it becomes what? 5. Is that okay? And I'll multiply with the e, and I'll still repeat the same function here as what? 5x plus 2. And we are done. That is all. That is all. That is all. Actually, that is all. So try this one for me. If I have y is equal to, try this one from y is equal to, let's say 3e to the power of 3x plus 1. How you differentiate this? So comment below your answer in the comment section. Let me see the answer you're going to get for the day before we look at the solution I'll present here. So here I can say that, or you are solving it from you solving. Let me see. Okay, your time is up. So let's see what you did. So I can say that my dy over the x is going to be, so I'll differentiate the 3, sorry, and I'm going to get what? 3. Is that okay? So it's going to be 3 and I'll multiply by, okay, let's see for the 1. When I differentiate the constant, I'm going to get what? 0. So the end result is going to put 3 for the differential of 3x plus what? 1. The end result is going to be what? 3, or the change is going to be 3. So it's going to be 3 multiply by 3, okay, and I'll repeat the e with the function that was given in the question, and that is all. So therefore I can say that my dy over dx is going to be 9 exponential symbol e with the exponential function s, 3s plus what? 1. 3s plus 1. And that's going to be my answer in this case. So let's take note of that. And this is where we bring an end to section 1 or part 1 of our journey that we have started on calculus under differentiation. So if the video was helpful to you, please go ahead to subscribe and make sure to like this video. That's all that I'm expecting from you, okay? Make sure to hit the like button, give me a thumbs up on this video so that we can get more engagement on this video, so that others can also get the benefits of this video and also learn alongside and to pass any examination they may engage on in the future. So I'll see you in the next video where we discuss other rules of differentiation like logarithm of a function, the quotient rule, the product rule, higher derivatives, and other rules that we need to know in order for you to understand the concept of calculus in relation to differentiation. So I'll see you for now. Bye bye.